But do we know our parent functions? And just to kind of prevent getting lost, check this out. If I have y equals x, what is y equals x? Y equals x is just a line, really. Y equals mx plus b. What about y equals 7? What's y equals 7? Y equals 7 is a horizontal line, like that. What's x equals 7? A vertical line. What's y equals root x? I've seen a question on the digitals like that. What's y equals root x? It's kind of like a half parabola like that. What's y equals maybe absolute value x? Makes a v. What's y equals x squared? Everybody's favorite, just a parabola like that. And anything else that we should mention? Any honorable? Yeah, actually, we all have seen this question, y equals 1 over x. That's a rational function. Remember, those are what have vertical asymptotes, oopsies, vertical asymptotes like that, and horizontal asymptotes, something like that. We're going to talk about that briefly later. No problem, Alex. So that's a rational function. Those have vertical asymptotes and horizontal asymptotes. Um, I think that's good for now in terms of functions. The last one would be exponential. Y equals 2x. Remember my Bitcoin example. I always tell you guys I have $10,000 doubling in Bitcoin. In other words, something like that. You could pop it into Desmos, but it helps to have an idea of what that looks like. That is exponential growth. Whereas what's y equals, I don't know, 0.5x. Imagine that's the population graph of Japan. What's that going to look like? That's going to be exponential decay. Understand that, yes, it's halving every time, every year. All right, so these are your parent functions. Really important to kind of understand those, even though you could just pop these into Desmos just to have a good idea. All right, boys and girls, remember that this is your reference sheet. It has a lot on there. It has your 45, 45, 90, 30, 60, 90 stuff on there if you need it. It has cylinder. It has a lot of stuff. But you know what it doesn't have? It doesn't even have density. Density is mass over volume. That might be worth writing down somewhere. I just saw a question working with Brian on that. Density equals mass over volume. Not given, but it's tested. The other thing is like surface area. I've heard about a lot of surface area questions on the test, and I know you guys have too. Volume is the space inside something. Surface area is your skin. In other words, how much surface area an object has. You guys have all seen that question with a cube, and it asks for the surface area. Well, what are you supposed to do there? You're supposed to find the area of one face and then multiply it by 6, because aren't there 6 sides to a cube? Yeah. So surface area is not given to you, but you should have a good handle on what it is. Now, the last thing that I'm going to kind of refer to all night tonight is this. A lot of you guys see these questions, and I don't blame you. Some of these questions are kind of wild, right? But when you're lost, you have some choices. The first thing that I would ask you to do when you're kind of lost and you see a question is first you have to frame the question. In other words, am I dealing with quadratics, linears? Sometimes you guys try to use discriminant for lines. Won't work. In other words, am I in lines? Am I in angles? Am I in triangles? Am I doing SOHCAHTOA? What am I doing? So that's the first thing I have to say. You have to frame the question. From there, you have so many options. You have Desmos. You have the ability to draw something to visualize it. You can use the answer choices. You can even assign values. You guys know that I love to assign x as 7 or x as 5 and just try. The last case, kind of last resort, is eliminate wacky choices. Yesterday, I had a girl tell me she was calculating the velocity of an eagle on the SAT. And she told me that the velocity was 11,870,000 feet per second. A falcon flying had a speed of like faster than the speed of light. So my point is, when you see a crazy answer choice, something that doesn't make sense, like an angle, like a fat angle like that, and it's 30 degrees, I probably wouldn't choose that. In other words, but right before you submit your answer on the SAT tomorrow, just have a second of doubt. Have 2 seconds of doubt. Ask yourself, is that really right? And the last thing is, look, you don't need a perfect score on this thing. I just had a student get a 21 out of 22. I've told you guys this a 21 out of 22, and then an 18 out of 22 on his test. Obviously, module 2 gets much harder, but he got 4 wrong. I mean, that's like a C in real life. But you know what? He or she got a 790 on this test, right? In that case, what that tells me is that, yeah, you don't need a perfect test. In other words, if there's easy questions, snap those up. Whereas if there's harder, really impossible Chinese-looking questions, maybe just don't do them until the very, very end where you know you got the rest right. All right, boys and girls, I'm about to start doing math. Again, as I go, if you have any questions or anything that I kind of zoom over and you don't understand, please message me or just stay after the session, and I'm happy to go back and answer any questions. So this session is to remind you or to clean any last little things up. As I go, I know I have some perfect scorers in here, kids that are trying to go for 750s and higher. If you already answered the question that I am answering, go off for the challenge or really harder questions off to the side. I'm not going to do every question with you guys. All right, I am officially done yapping. Let us begin with some math. So the first skill that I want to just remind everyone is 30, 60, 90. The second I see root 2 or root 3 in the answer choices, I have alarms going off in my head. In other words, if this is 30, this is 60. Remember that half of the hypotenuse will be the side opposite of the 30. In other words, half of 12 is 6, 80 is 6. Done. I have some more. Come on over here for this one. Down here it says, if the radius is 7 of this figure, then the whole thing is 14. Understanding that that's 30 and that's 60, again, I have alarms going off in my head. What's PR? Well, remember, in a 30, 60, 90, it goes x root 3, 2x. Therefore, isn't this going to be 7 and this 7 root 3? What's PR? 7 root 3. Cool. All right, I am going to keep going. Again, if I'm going too fast, just let me know. The next question is over here for 45, 45, 90. Keeping 45, 45, 90 on the left side of your screen, how does it go? It goes x root 2. Now, I'm not the smartest guy in the world, but I'll never get this question wrong. You know why? Because drawing myself a triangle here, if the hypotenuse is 58, first of all, is the perimeter going to be A or B, or are those wacky answer choices? Those are trash. Now, look at C and D. D implies that this is 58 root 2, 58 root 2. Is that possible? Is that possible that the other sides are bigger than the hypotenuse? Nah, man, that's trash. D is trash. The only answer is C. Now, even if I didn't understand this question, really, it isn't easy. This is 29 root 2, and this is 29 root 2. Therefore, this is 29 root 2, which gets you to 58. That's not easy to see. But I'll never get this question wrong because I just will use the answer choices. Okay, so that's 45, 45, 90, 30, 60, 90. Again, if you want some challenge questions, I have one over there. I have another one down here, and I have some in the back if you want to stay after. But the next skill I want to come down to is right triangle trig. Right triangle trig is arguably maybe one of the most important topics. It was one of my students told me that it was tested 3 times on his last test. So let's make sure that we have it. First of all, for this question, I would draw my right triangle. Framing this question, it's SOHCAHTOA. At that point, if this is angle K, this would be cosine is adjacent over hypotenuse. Now, it wants cosine of L. It wants cosine of the other angle. Well, the problem is I don't have that other side. What formula allows you to find the third side of a right triangle? Our Greek friend, Mr. Pythagoras, says a squared plus b squared equals c squared. When you do that, you get 45 here. Now, to finish off this question, what's cosine of L? The other day, Justin left his answer as 45 for this question. He just submitted 45. That's wrong because he wants cosine of L. That's adjacent over hypotenuse. And if you, to be honest, the first time I did this question, no, Tiago, that's wrong. I left that answer as well. It's wrong. It's wrong. The SAT will give you 0 points for that. Why? Because that's not simplified. When you simplify that, it's 15/17, and that's the only answer that the SAT will accept here. So that's a lesson to us for tomorrow. Only submit simplified fractions. And then earlier I had a student submit like I forgot what he said, but he said 1/6.5. Can you submit, would the SAT take that? I mean, they'll take it, but they're not going to give you points for it. They will never take a decimal inside a fraction. That's crazy. Be careful with that. The only other thing I'd say when you're submitting your answers is decimals. If you're submitting a decimal, to be honest, the only time I submit a decimal is when it's a clean decimal like that, or if it's a repeating decimal like this. 6.556 can be an answer. Remember that the SAT will only accept 4-digit rounding. Again, you need to go to 4 digits. If you get some weird irrational number earlier this morning, some student submitted 1.07347 or something crazy like that, it's wrong. It's already wrong. You know that if you get a weird answer like that, it's wrong. Almost every answer to the SAT will come out nice and clean. Even repeating answers are somewhat clean. Let's keep going. So the next skill I want to talk about is something that's tested all the time. For my 700 plusers, you guys can try this quickly if you want. But for this one, this is similar triangles. Remember that if I draw similar triangles, what's special about similar triangles? Similar triangles have same angles. Again, congruent triangles are the exact same, but similar triangles are the same angles. So watch this. If angle F corresponds with angle J, again, if angle F corresponds with angle J, and they give me angle F and they want angle J, what? Remember, similar triangles are the same angles. So they'll have the same trig ratios. Again, similar triangles have the same angles. So they will have the same trig ratios. It's done. Cool. So that is good there. The last topic that I can talk about, Brian and I just did this question. It's a really hard question, to be honest. I would love for you guys to try that later on your own time if you want. But this is similar triangles. On your test somewhere, you're going to get little baby big mama triangles. The idea is that they're proportionate. In other words, watch. If I want CE here, what am I going to do? Well, 6, 8, 10. That's from Pythagorean theorem. From there, check this out. 6 is to 18 as 10 is to 30. This whole leg would be 30. Cool. So those will always be proportionate. You have another trig question here, a SOHCAHTOA question here, if you guys want to try that afterwards or ask me about that afterwards, just mark that down. I'm going to keep going. We have a lot to do. The next thing that I'm going to talk about is fractions. Really quickly, what can the bottom of a fraction not be? The bottom of a fraction cannot be 0. And then a lot of students say C. It makes me really sad. Really, the idea is you want to set that equal to 0. X plus 5, x minus 2 equals 0. What values make this 0? 5 and 2. Therefore, the answer is D. Okay. Now, let's keep going. I'm not going to do this question, but I'll just talk about it for just 10 seconds here. Ready? When you're adding, subtracting fractions, you need common denominators. So what do you think I should tack on to this one, the bottom and the top? An x plus 2. An x plus 2. I might as well just finish this damn question. Watch this. This -2 will distribute. I have 2x plus 6 minus 2x minus 4 all over x plus 2 squared. And that's a good lesson. That negative distributes with it, right? From there, 2x and -2x cancel. What's 6 minus 4? I'm left with 2 over the denominator. What do you think the answer of A is? It's 2. That's adding, subtracting fractions. Cool. Let's keep going. The next question I'm going to do is this one down here. Very similar to that previous one, adding, subtracting fractions. But you know what? One of my students who isn't good at math at all, but he has like a 700 on this test because he's a Desmos god. He pops this into Desmos. He pops this. I mean, he doesn't do all of them because he gets the answer eventually. He pops that into Desmos. He sees that something looks like this. Then he pops this into Desmos, and he gets something that looks like that. What do you think? It's the answer. If you guys want to see me work that by hand, I'm happy to afterwards. But yeah, there's a whole section coming for you that's labeled Getting Dirty with Desmos. And the idea there is that, yeah, Desmos is so, so powerful if you're good with it, right? And would you look at that? Look at where we are, getting dirty with Desmos. So let's take a look at some of these questions. To be honest, I'm actually going to do one question. And for the first time this lesson, I'm going to ask that you guys try a question. This is the one I'm going to do. This is number 22, and you guys are going to do 20. So please check this out. They're almost identical questions. So everyone in this chat can get this right. What's the idea here? I mean, I think it's quadratic formula. It is a weird quadratic that's not factorable. So I should do quadratic formula, but man, my tutor's not good. He didn't really teach me quadratic. I don't really remember quadratic formula. Oh, fuck. All right. Well, we always have Desmos, right? So let's pop it in here, 3x squared minus 6x minus 11. At that point, I'm going to pop both of those in. And remember, I can write them down. That's 3.16025 and negative 1.16025. I think this is called the Jackson method. One of our students in here figured this method out. Really, really smart. He's not the best at math, but he's smart. Now what? Well, if those are the two values, I'm kind of lost, but I'm just going to pop this in. 3 plus rad 3, or 3 plus rad g, I'm sorry, divided by 3. He then added a slider, and he just dug around. Check this out. He just tried to match up. Remember that value of 3.16025? He tried to match that up. No, let's go bigger. Let's go to 50. Oh, that's too big. Okay, let's slide down. 3.16. Yep, that's the one. The answer is 42. So this question's beautiful because it really teaches us how to use Desmos and how to just finesse, right? So that is number 22. The next question I'm going to give, I want every single person in this chat to send me. You can private message me. You can direct whatever you want, public message. I want everyone in the chat to get this question right. Go ahead and try 22 when you're ready. You can do it the real way if you want, but I don't know. You're right around a minute here, guys. Come on. Once you have your answer, please send me a picture or just send me the answer when you're ready. Good job, Brian. Brian's a Desmos god. Anyone else? No, Tiago, run it back. And again, Tiago, you know that's wrong. You get that weird ass answer, you know it's wrong. Good job, good job. Yeah, Jackson, it's good. Jackson, why are you asking me? That's your method, my boy. Good job, Dylan. All right, guys. If you're still working, go ahead. But I just want to show everyone how to do this one. Of course, there is a real way. You should know how to do quadratic formula, but it's just faster to teach you Desmos. Check this out. I have x squared minus 10x plus 14 equals 0. Those are my two values that I'm looking for. At which point I'm going to pop this in and go 5 plus n, 5 plus radical n. Add a slider, and just slide until I get one of those answers, 8.3165. Nope. Let's go to 15. That's too big. Too big. Done. Do those two numbers match? Yes, they do. Very good. All right. Proud of each and every one of those of us that got that question right. Really important. And that I'm not going to do this next question unless you want me to, but this next question is almost the same idea. Really, I would pop both of these into Desmos and then see when these two lines have no solution. This is probably the most commonly tested skill on the SAT, on the digital. Every single one of us has done this maybe 100 times. Again, I would run a slider and slide, slide, slide until I get these two parallel. Cool. Um, sometimes I have students that say, "Oh, nothing popped up on Desmos. Nothing popped up." Yeah, and that's at that point, don't give up. Just try setting equal to y. Try something, right? You got to try something. Or like sometimes I had a student earlier, there was a question with W and X's or W with T's, and nothing was popping up. What should he do? Switch everything to X's and Y's, right? Okay. So let's come on down here for just a few last questions on this topic. This question. If I gave everyone this question, I bet only 10% of you, only like 1, 2, or 3 of you are going to get this question right. Because yeah, you can't Desmos it. Does anyone see a function to Desmos here? Is there anything to do? No. And this is why I have that kind of checklist here. Yes, you should Desmos. Yes, you should backsolve. Yes, you should assign values. Yes, you should eliminate bad answer choices. But what can you do? All you guys in my Zoom sessions, you guys are always like, "Ah, man, I got nothing. I'm lost." That's unacceptable. We got to come up with something. Give me something. And if that something means a drawing, check out how much a drawing helps for this question. If I draw an XY plane, and this is easier than Desmos. Drawing is easier than Desmos here because there's no function. Okay, I know it goes through 2, 0. I know that it goes through 3, 2. And I know that it's a quadratic facing down because it's a maximum. Huh, okay, so I literally just followed everything they just said. At that point, Brian knows that, what's the other solution here? What's the other x value? What's the other solution? Well, gun to my head, if I had to choose an answer, is it going to be -2? Is it going to be -16? Is it going to be 12? No, man, it's going to be 4. The answer here is B. And why? Because remember that a parabola has an axis of symmetry. If this is 2 and this is 3, this will be 4. Okay, so my point with this question, maybe we've done this before, maybe you know this question, but yeah, the answer here is B. If you want me to show you the real way to do this, this is the real way to do it, but there is algebra here that you could do as well. The algebra is insanely difficult. Not insanely difficult, but it's a lot. But yeah, this drawing helps a lot here. Dylan, did you want to see the actual algebra or no? Okay. To be honest, the actual algebra is extremely long. It has to do with vertex equation of a parabola. It has y equals a x minus h squared plus k. Honestly, that could help everyone here. That's vertex form. At that point, you know what you'd do? You'd pop this in as h and k, and then use this coordinate 2 and 0 to solve for a, and then solve for the other solution. It's the algebra is insane. So that's why a drawing helps a lot there. Dylan, if that helped, let me know. But if not, we can always come back. All right. The next one is arguably maybe the next most important skill on here. It's the idea of percent. The idea of percent. Dylan, if that explanation didn't make sense, just stay after. I'll explain after as well. So percent. Percents are extremely important. Let's help our friend Hongbo right here. Hongbo said that, oh, his phone sales increased by 128%. Increased by 128%. If I increased by 128%, where am I at? Remember, everything starts at 100%. If I increase by 128, where am I at? 228. I'm at 2.28x. From there, the next year was 29% greater. What's up 29%? 1.29. The answer is D. If that makes no sense, please let me know. But let's keep going. There are a lot of good questions on this topic. I just pasted this question in. I was working with a lovely student, and we almost got this question wrong. This question says, the population of a city was 2.6 times the other population. How much of an increase is that? And this goes back to the words of versus increased. Well, 2.6 times of that, or 260% of that, is just 2.6. But how much of an increase is 2.6? Remember that everything starts with 100%. Jack, if I start with 100% and I ended up with 260%, how much of an increase was that? Ah, that was an increase of 160%. The answer here is 160%. And we'll do another one of these in a second. But yeah, this is a big, big trap. All of your friends who aren't studying are all going to put 260 here. But the answer is 160. Because how much of an increase was it? The other question that I really love here is probably this one, 27. This skill has been showing up a lot on these SATs. Let's try this one real quick. If you have any questions, again, just ask. But let's read. It says 210 is p% greater, again, increased from 30. Well, I would say 30 to 210, that's 700%. All your friends are going to put 700% tomorrow. And you know what? They're all going to get it wrong. Why? Well, because think about it. If I'm 30 and I went to 210, how much of an increase is that? How much did I gain? I gained 180. And 180 is what percent of 30? How many 30s is that? It's actually 600%, or like 6 of them, right? So 600%. What's the answer here? It's actually 600. All of your friends are putting 700 there. Okay, I'm going to zoom out, let everyone soak that in for just a second. If that made no sense, tell me that I'm a shit teacher and I'll take it. I'll try one more time. But if you do want to do any of those other questions, be my guest, or we can do those at the end of the lesson as well. All right. In that case, the next few questions down here are coming down with lines. For whatever reason, I really can't get you guys better with lines. It must be me at this point. I really can't get you guys better with lines. But even before we do lines, just talking about inequalities. Desmos does a really nice job of solving any inequality question you have. The only thing that you want to do is find where they overlap. Again, find where they overlap. That will be your answer. Okay, so in a question like this, I'm just making this up, but where do they overlap? They overlap in this region. So any answer you choose has to be in that region. That's if you want to do this in Desmos. If you want to do this for real, it's so easy. You just plop in, pop in your X's and Y's and see if the statement is true. In other words, is 5 greater than 1? Yeah, if so, then yeah, it works. If not, then it obviously is not the answer. Okay, so that's inequalities in just a nutshell, really, really fast. Okay, like I was saying, I'm going to come down here for lines. I'm hesitant because I don't want to waste too much time here, but really, y equals mx plus b is our Lord and Savior. I'm just going to do one question, just because I've honestly almost never had a student get this question right for whatever reason. I'm going to do one question, and you guys can tell me what you think. And it really ties us into our next lesson as well. This is the question I'm going to do on lines. Remember, even before I start this question, I know that I'm in the mode y equals mx plus b. And boys, do you see any function to be able to Desmos here? Is there anything to Desmos? No. So we actually have to have some knowledge here, unfortunately. So let's take a look. First of all, let's just read the question. It says, there is this table with values. Remember, these are X's and these are Y's. It looks like this line was then translated down 5 and then wanting the x-intercept. Again, I want to translate this down 5, then find the x-intercept. So you know what that tells me? That tells me I have a game plan. You might want to have a game plan for these harder questions. You first want to find the y equals mx plus b. Then I'm going to subtract 5 to translate it down 5. And then I'm going to use Desmos or just my brain to find the x-intercept. How do you find an x-intercept? You set the y to 0. So that's my game plan. I'll say it again. Find the y equals mx plus b, shift it down 5, and then set the y to 0. Okay, let's do that. First of all, how do you find the y equals mx plus b? The slope, the rise over run. The rise over run here is it's rising 30, running 5. That's a slope of 6. I have y equals 6x plus b. At that point, you guys are not good at this step. How do I find these 3 letters? What do I do with these 3 letters? Well, I have 3 unknowns. I can never solve that. What I should do is pop this in for x and pop this in for y. At that point, I have 130 equals 6 times 18 plus b. You solve and you get b equals 22. I'm going to say that one more time. Really, you have 3 variables. You can never solve that. But what do you have sitting here in front of you? A coordinate. If I could get a tattoo, if I had a tattoo, I would get a tattoo that said plug it in. Plug it in. When you have a coordinate, plug it in. Now what? Well, now I have y equals 6x plus 22. That's the equation of my line. Now I'm going to subtract 5. Y equals 6x plus 17. Like I said. And now what? Now I'm going to set the y to 0 or just pop it into Desmos and find the x-intercept. First of all, you can just look at the answer choices. It's going to be D. Good, Dylan. That's exactly. Cool. Tiago, I'm looking at what you did, but I'll look at it in a bit. Okay. All right. So that is good there. That's y equals mx plus b. And that really lines us into our next topic, which is translations. The SAT, the digital, has been loving translations. It's your job to know what translations are and what they do. Just to remind everyone really fast, if I have f of x plus 5, f of x minus 5, f of x plus 5, f of x minus 5. I know I beat this to death, but I'm going to do it one more time. This is a translation 5 to the left. This is a translation 5 to the right. This is a translation 5 up. This is a translation 5 down. Now, we can do a few of these questions just really quick. Take a look at this question on the left. If I shift this function what? Oh, if I shift this function 2 to the left, what's my y-intercept? If I shift this whole function 2 to the left, what's my y-intercept? It's 3. Okay. Cool. So that's good there. Come on down here with me. We're going to do a few more translation questions. I would say 95% of my students have gotten this question wrong in the past. There's a real way to do it. I've probably taught some of you guys the real way, but let's try it the fake way. What I would do, and I'm just going to talk about it, to be honest. If anyone wants, or if anyone has questions afterwards, please let me know. But what's happened to this question? It's been shifted 2 to the left. So you know what I would do? I would pop this into Desmos, and then I would pop the answer choices into Desmos and see which one of them really took my original function. Of course, an exponential function. Come on, notability. All right. So imagine I have an exponential function, and I'm just going to go through the answer choices A, B, C, and D and see which one of these really just shifted me to the left 2. The answer here is B, in case you want to check it out later. But yeah, it's that easy. For a question that's kind of hard, this is labeled a 3-bar difficulty question. You could just pop this into Desmos and see which one of these shifted it to the left 2. Okay. Okay. Let's keep going. That's a lot of translations. And I'm gonna do one last translation question. Can't you also do? Yeah. Yeah, you can. You can. You can. Dylan, I like that. Let's do this last question here. This last question for translations. I want everyone to listen to this because some of you are going to get this wrong tomorrow. Everyone gets this wrong. I don't know why. Look, sometimes they want you to shift something, and sometimes they want you to shift it back. Everyone has gotten this question wrong. Check this out. The graph of the linear function shifted up 19 is already shown. I'm going to say that again. The graph already shifted up 19 is already shown. What do you need? What do you think you need to do to get it back to the original? You need to shift it back down 19. At that point, don't really worry about numbers because look at the answer choices, right? There's no answer, there's no numbers in there. So my point is, if I have to shift this down 19 to get back to the original, do I have a positive or negative y-intercept? Do I have a positive or negative slope? They're both negative. It's A. Okay. Again, the reason I put this question on here is because a lot of us aren't understanding this. In other words, it's already shown. The shift has already been shown. So in order to get it back down to where you started with, pull it back down 19. Okay. All right. Boys and girls, we are absolutely zipping through this. I am going to skip some of this stuff. Again, if you want me to go back for it, please let me know. If anyone gets this question wrong tomorrow, I'm going to scream. This is definitely going to show up tomorrow. We just have to be clean. Remember, I started with $500. I increased by 2.5%, so that's 1.025 to the x. It's b. We've done these a million times. If you want to practice with the rest of those, you can. Okay. Come down here for this part. This part is not desmosable. So yeah, if I were you, I would definitely listen up. There are 3 cases with exponential interpretations. There's $10,000 doubling every year. There's $10,000 doubling once every 5 years. And it sometimes helps to just write a 1 there. Once every 5 years. And there's $10,000 doubling 5 times in 1 year. The SAT can test all 3 of these variations. Again, this is $10,000 doubling every year. This is $10,000 doubling once every 5 years. And this is $10,000 doubling 5 times per year. You have to be aware of every single one. And how do we apply that? Check this out. Just an easy question for you right now. Check this out. This person started with $60. It's tripling once every 2 days. The predicted number of organisms triples every 2 days. Too easy. All right. Let's just do 1 or 2 more of these questions just really quick. Let's do this topic is tested every single SAT. Really, with a parabola. What is the interpretation of 72? What is that guy in the back? It's the y-intercept. In other words, this has started at 72 and jumped off. And a new trick that I'm trying to tell students or trying to teach students is if I'm lost, if I don't understand what's going on with an interpretation question, just pop this into Desmos. Just to get a feel for it. I know as a teacher what that looks like, but I mean not everyone does. I would pop that into Desmos and get a feel for what's happening. You will never miss an interpretation question again if you pop these into Desmos. Okay. I'm skipping a little bit. Just really quickly, just like flashcards, right? Check this out. If I'm 55 degrees in the back of the eye, what am I in the front of the eye? 110 degrees. Yeah, good. The next flashcard is number 34. Watch this. How do I find the slope of this red line? How do I find the slope of that red tangent line? It's perp. Really, it's opposite reciprocal from that blue line. Let me show you. Again, how do I find the slope? It's asking for the slope of that red line. How do I find that? Well, check this out. This is going down 4 over 3. Rise over run. It's rising down 4, running 3. What's perp to negative 4/3? 3/4. Remember, perpendicular lines are opposite reciprocal. Parallel lines are same slope. So yeah, the answer here is 3/4. All right, let's keep going. We do have a lot more to get through. I'm just trying to remind you guys of all these little skills. This is everybody's favorite skill. Remember that because this is an area, this is a two-dimensional object. How many times do I have to apply my conversion in a two-dimensional object? Twice. How many times do I have to apply my conversion in a three-dimensional object? 3 times. So what am I going to do? I'm going to do 11,863,808 divided by 1760 divided by 1760, and you get B. Again, for a two-dimensional object for area, you have to apply that same conversion twice. For a three-dimensional object, you have to apply that conversion 3 times. For my students that are headed for not 900s, but like 800, 750s, if you guys want to try this one or do this with me later, please do. That's kind of like the hardest of this variation that I have. But we'll just do one more, an easy one. It says that this trapezoid has been multiplied by 8 times on every single side. But really, the area of a trapezoid, what's area? It's two-dimensional. How many 8s have been applied? Really 2. In that case, if this has been 8 times twice, times 8, times 8, twice, what's the answer? Cool. Again, if you guys want to try 19 as a challenge question, please do. And we can do that later if you want. But I'm coming off of dimensional shift. All of this stuff is Desmosable. This whole page, finding the minimum, is Desmosable. The only thing that I would warn you of, and listen up, listen, every single one of you guys. My girls listen to me, my boys don't. Really, check this out. This is asking for the minimum value. Is that the y or the x? It's the y. This one says, for what value of the x does the y reach its minimum? Is that the x or the y? That's the x. Cool. So that's really you guys just don't follow instructions. That's the only thing I'm worried about for you guys. What about number 22? How many distinct solutions does a quadratic like that have? Again, I would pop this into Desmos. To be honest, I'd probably set it equal to y, or else it's not going to show up because it turns out that there's no solutions. But yeah, remember, the reason I'm giving you this question is to remind you that that's no solutions. That is one solution, and that is 2 solutions. Okay? That question shows up all the time. All right. This next question's a beauty. Really, again, going back to that idea of when you have a coordinate, plug it in. If you're lost tomorrow and you have a coordinate and you don't plug it in, I don't know. I have failed you because look, I have 1, 2, 3 variables. Again, I have y equals 3x squared minus bx plus 12. I have 1, 2, 3 variables. I can never solve an equation with 3 variables, but Colin knows that I actually have 2 of them right there. In other words, inside a coordinate is an x and a y. Why not pop this in for x? Why not pop that in for y? And now how many unknowns do I have? Just 1. So if you solve that, you should get the answer. I think Jackson did this on Desmos yesterday, so you could even do Desmos. I don't even know how you do this on Desmos, but yeah, I think the answer comes out to 11. Try that later if you'd like. Let's keep going. The next topic I want to talk about, just really briefly, there's a few challenging questions. To be honest, these 2 questions at the bottom are extremely difficult if you want to try those, if you're an algebra wizard. But for now, I just want to do one of these. This is called solving for a variable. The SAT loves this. There's always one on every single test. The idea behind this is you want to solve or really get the V alone. Again, you want to get the V alone. If I want to get the V alone, first, what should I do with these? With that trash on the right side, just move it over. I have h plus 16t squared minus k equals vt. At that point, I want to get the v alone. What should I do with that t? Divide everything by t. And at that point, you should see that the answer is going to be D. Again, let the answer choices guide you a little bit here, but the answer choice really is D because, yes, the h and the negative k will sit on top of the t, but they cancel out a t squared with a t on the bottom. Kind of annoying that they did that, but it is what it is. So on the test tomorrow, your job is to get that variable alone. And you know what? Sometimes I do get lost on these questions, especially the hard ones. But then I reroute. I just tried a different way, and I let the answer choices kind of lead me, right? I follow them. Okay, that's enough of solving for a variable. I want to come down here and go over to this. Oh my gosh, there's two really beautiful questions. You guys are killing that question on the right, but this is such a beauty. This is gonna show up tomorrow, and I want everyone to be on the edge of their seat for this skill tomorrow. This question, just by looking at it, is screaming systems of equations. Desmos can solve the system, but you need to be able to come up with the equations. Check this out. I would do x plus y equals 60, 2x plus 4y equals 202. Again, you can go back and read that, but look, 60 tens, two types of tens, two-person and four-person tens have to add up to 202 people. These are my two equations. At that point, I would pop this into Desmos and then find where they intersect. But you guys are actually still getting that wrong even with that because y'all are giving me the answer for the four-person tens. Be careful. Which one is X? Which one is Y? You have to be careful with which variable you choose there. But yeah, the answer comes out to 19 here. Now, I did those two equations for you, but on the test tomorrow, you need to be able to come up with those two equations. So if that didn't make sense, if that didn't help, please go back and try this one later. Cool. So again, I would just use Desmos to solve it. You don't need substitution. You don't need elimination. Just pop it into Desmos. I'm going to keep going. If you guys have any questions on the way, just holler in the chat. I am watching it. The next question here is absolute value. The next topic is absolute value. Luckily, Desmos even has an absolute value feature. So just pop this into Desmos. It turns out that when you do the algebra, if you actually try doing this by hand, you get both C. You get both answers in C. But it turns out that -5 is an extraneous solution. Desmos would never betray you like that. Desmos actually just straight up gives you the answer. It's B. Make sure that you play around with Desmos. Make sure you know how to do absolute value on there. But this next one's actually kind of funny. Jack got this really easily. When will an absolute value give you a negative value? Dylan, when will an absolute value give you a negative value? It can't. It's 0. That's a weird one. Just watching out for that. All right. We are coming to the kind of I don't want to say halfway point, but we are almost done. I'm gonna skip the factoring for now just because I do want to come down to statistics though. Statistics are, yeah. Tiago, what's your question with the first absolute value? Just real quick. Tiago, just to be clear, I would just pop this straight into Desmos. That's weird. Tiago, stay after. I'll go over this at the end. But yeah, it should give you the right answer. It should be B. Okay. All right. Let's come down to statistics. -2. I don't know what you're doing, Tiago. We'll try together. But yeah, statistics are super duper important. Remember, they can test a few different things. They can test probability. They can test mean median, mode, range, standard deviation. And actually another thing they could test is margin of error. Margin of error. I've only heard of it on one of these digital tests, so it's not probably common, but it can be tested. Just to remind everyone, mean is the average. You add them all up and divide by the number of. In other words, if I got a 79, a 91, and an 85 in a class, I would add them and divide by 3. What's median? Median is the middle. And I'm going to teach you guys that. That's called slap off. In other words, I slap off the top, slap off the bottom, slap off the top, slap off the bottom until you get to the middle. Mode is the most frequent. Mode is the most frequent. In other words, if 7 shows up 5 times, again, if 7 shows up 5 times, maybe 7 is the mode. Range is high minus low. Standard deviation is the spread. How spread from the mean am I? How much have I deviated from the standard? And margin of error we'll talk about in just a second. Okay. If you guys want to try these probability questions, we might have done this before, but they are good ones. Coming down here for margin of error. Everyone gets this topic wrong. I used to get this wrong when I was your age. It is just very backwards. But the idea is that if this person has a bigger margin of error than this one, has this person practiced all that much? And the example I always give is free throws. If I throw 10,000 free throws versus I'm just a math teacher, I'm trash at basketball. If I just throw 10 free throws, I'm going to miss like 90% of those free throws. Whereas if Kevin Durant shoots 10,000 free throws, he's not going to miss as many as me proportionately, right? In other words, is KD's margin of error going to be higher or lower than mine? He's practiced a lot. So my point is, because this person has a higher margin of error, they have a smaller sample size. This person is Steph Curry, whatever. This person has a very high sample size because his margin of error is so low. He doesn't screw up at all. His margin of error is very low because his sample size is so high. So the answer here would be D. Sample A has a much smaller sample size because they screw up so much. They're not good at what they do. Okay. The next topic I want to talk about, the more obscure topics I want to talk about is box and whisker plots from statistics. Really, they think the SAT loves to test this idea that the box and whisker plot tests mean or talks about mean. It doesn't. Box and whisker plot is min, max, and median. Again, min, max, and median. Anywhere in there, did I talk about mean? No. So this is trash. The only answer is B. So range, of course, is high minus low on a box and whisker plot, but that's good. All right. I was going to say boys and girls, but just boys. Let's keep going. I'm coming down here for standard deviation. You have 4 standard deviation questions here if you'd like to try. This was tested on the most recent SAT, so it's probably worth your time. The easiest one to learn from is this one. This one says, what is the difference in their standard deviations? Well, look, this one is much more tight-knit. This one is much more loosey-goosey. In other words, this one is spreading a lot from the mean. It's deviating a lot from the standard. This one's not deviating a lot from the standard. This one has a smaller standard deviation because it's tighter. It's tighter knit. In that case, I would answer with C. The standard deviation of R is less than the standard deviation of S. Again, standard deviation is the spread of the data. All right. That is good there. If anyone has questions on standard deviation, just stick around. We'll do some more. Now, another topic, I have another question in the back, Brian. I know we just did this question, but if you want to do it, actually, we didn't do this one, but I have another one in the back. This one is talking about outliers. Outliers. Now, think about it. If if I have some houses, if the houses around me are worth 500K, 600K, 700K, and let's just say 900K, the houses around me are kind of around that price. But then Jeff Bezos and Elon move into my neighborhood. What's going to happen to my mean? Do outliers affect the mean? Yeah, they jack up the mean. It's crazy. That's why actually, if you look at demographics and studies like that, they never use mean. You know what they use? Median. If you've ever heard the term median adjusted income, median adjusted household income, or whatever, you know why? Because median, you know what median does? Median slap, 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 slap. The median is barely affected by outliers, whereas the mean is very affected by outliers. So taking a look back at this question, a lot of you guys grab your calculators and try to find the mean, try to find the median. You don't have to do that on the SAT. If a kid that's 60 inches joins the group, again, don't touch your calculator. What's going to happen to this data set? Well, remember, slap, 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 slap. The median is 54. It turns out that the median can stay the same, whereas the mean will get jacked up. Yeah, good job, Tiago. Yeah. So again, outliers affect the mean. Outliers don't affect the median. The SAT loves to test that idea. Now, on that note of median and slap, 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 this is something that every single one of you guys have either learned from me or something. This next question is asking for the median. But on tomorrow's test, remember that this is a histogram. It's a frequency table. In other words, how many times did 10 show up? 4 times. A lot of my students sit here and just do 10, 10, 10, 10, 11, 11, 11, 11, 12, 13, 14, whatever. They sit there and go slap, 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 slap. They sit there for half an hour. Check this out. This is the slap method. I'm going to slap 4 off the top, slap 4 off the bottom, slap 4 off the top, slap 4 off the bottom, slap 2 off the top, slap 2 off the bottom. Really, the median must have been 15. And of course, you don't have to go that fast or whatever, but my point is, you just want to slap some off the top and slap some off the bottom until you get to the middle. Again, slap 4 off the top, slap 4 off the bottom, slap 4 off the top, slap 4 off the bottom, and you find that, yeah, the median will be 15. Median, just think of slapping off the top and the bottom. Okay. All right, let's come on down here. Now I'm in the random section. Really, this is just like free-for-all random stuff that the SAT can throw you. One of them is imaginaries. If you guys have a TI-84 or a graphing calculator, your graphing calculator can do this for free. Just remember that second period is I. So honestly, if I were you, I would just pop this right in to my graphing calculator. Honestly, Desmos could probably do this for you too as well. But yeah, I would just pop this right into Desmos, or for my math nerds, you know that I squared is equal to -1. So again, I don't know if this will show up tomorrow, but you never know. Yes, you are allowed to bring your TI-84 and Desmos. You are allowed to bring your calculator and Desmos. Okay, the next skill that I want to talk about is radians. Some of us have just started pre-calculus. For those of us, please listen up. And for those of us that slept through all of pre-calculus last year, you know who you are. This is important. Really, the idea of radians. What is 1 pi radian? 1 pi radian is 180 degrees. Really, what is that pi right there? It's 180. So 7/6 times 180. I think you get 210 here. That's it. Okay. All right. And for those of us that aren't in pre-calc or are in stats or whatever this year, please stay after if you want me to repeat that. If you want me to show you how radians work, it can show up. It has been showing up. Now, the next question is arguably the most important question, and we'll start with the easier one. The next question is arguably the most important question for every single person in this room, even if you're headed for the 750, 760 tomorrow. It's the idea that f of 2 equals 3. This is like my totem. I always hold on to this because you know what this does? This tells you that when you plug in 2 as x, you output 3 as y. I'm going to say that one more time. When you input 2 as your x, this is your input. This tells you that you output 3 as your y. And who cares? Well, it's because for a question like this, some of you plug x in as -2. Is that what this question is saying? No. What this is saying is it's saying y equals -2. Y equals -2. In other words, you need to plug -2 in for y. From there, you have to solve that. I think you get D, but that's if you go the other way, it's wrong every time. Every time. And you know what? That's an easy question. Colin laughed at that yesterday when I gave it to him. He's like, what? I'm in AP Calc BC, bro. What are you talking about? This is a joke. Yeah, I know. It's a joke. But if you can't get this question right, you can't get the next question right. And I think every student in here has missed that next question. Again, what is this saying? This is saying that y equals -2. You plug this in for y. The reason I bring this up is because look at this next question and look at any question tomorrow that shows up like this. This is saying what? This is saying very similarly, you have this weird setup. This is saying that when you plug this in as your input, you output 0. Is it not the same exact identical story? It is. My point is, when you input this, you output this. So I'm going to pop in this as 0 equals h minus 3 minus 4, h minus 3 plus 1 squared. Look at what I did. Every time I saw an r, I popped in h minus 3 because that's what it said. At that point, what are your final answers? What values actually zero this out? Both 7 and 2. Good job, Tiago. That's exactly right. It could be either of those answers, but yeah, that's the idea. Again, the previous question was easy. This one's a little harder. This is your input and this is your output. Yeah, this type of question shows up every single SAT, I promise. In some capacity, right? Okay. Any questions on that before I move? Of course, I'm happy to kind of come back to this. I am going to finish up with just the last few ideas down here, and then y'all are free to leave. This is another radian question, just really quickly. How many radians is 720? Well, what did I say? I said the conversion is 180. Divide 1 pi radian is 180 degrees. So when you divide that by 180, you get 4 pi radians. Really, the answer here is 4 pi radians. Again, for those of us not in pre-calc or haven't seen that, 1 pi radian is 180 degrees. All you have to do is divide by 180. Or if you want to get out of radians, multiply by 180. All right. So just about done here. Coming down here for this one, I just went over this student with a really bright student. He instantly got this question right. Let's try this question together. It says, a sample of 50 employees from the finance department at company XYZ was selected at random. The 50 employees completed a survey about a website's ease of use. And 72% of them thought the website was easy to use. Which of the following is the largest population to which the results can be generalized? I'm going to say that one more time because I almost had a stroke reading that. 72% of 50 people in the finance department at company X said that the website was easy to use. What's the largest population that this can be generalized to? And the way to think about these is if this is the base population that was tested, this was just 50 kids in the finance department. Can I generalize that to everyone in the US, even in Hawaii where they're eating poke and spearfishing their lunch? Is it going to be applicable? Nah. All companies, even the market, even like the creative design, graphic design department? Nah. What about D? All employees in this? I mean, If it's just the sample, if you're just going to generalize this to the sample, why'd you even do the study anyways? My student earlier was really bright to say that it was C. In other words, you can only always generalize something up one level. So if you had 50 kids in the finance department, now you can use that study to generalize to the whole finance department. That might show up, you never know. Let's finish with coming down here. There are some good questions. This is a unit circle question. If you guys are in pre-calc and want a refresher, I can give you that in a bit. But coming down here, let's just finish with one or two last questions. The idea of how to know when triangles are similar and when to know when triangles are congruent. Again, how to know when triangles are similar and when to know when triangles are congruent. Well, let's first talk about, I actually have two more questions on this if you guys want to see them afterwards. But similarity. Similarity is when you have a little baby, big mama. In other words, yes, their angles are all corresponding. All their angles are corresponding. So for 24, this question is extremely difficult, I think. The idea is that, yes, these two angles, first of all, are the same. Now, I had a student yesterday, really smart student. He said that parallel doesn't matter, that DE and HG being parallel don't matter. I gotta push back on that because look, imagine if this line was like this. Doesn't that throw off every single angle here? In other words, is that angle corresponding to that? Is that angle corresponding to that anymore? Nah, it's dead in the water. We need to. We need to know that this line and this line are the same. And to rant about that for just a second, everyone listen to this. This is the idea of transversals. If I have a line like that and two parallel lines like that, if I prove to you that these are two parallel, check this out. This angle, this angle, this angle, and this angle are all the same. They are all congruent. However, if I then switch this, if I say that they're not parallel, everything is dead in the water. Nothing is parallel anymore. Nothing is congruent anymore. Yeah, that's a really good question. I have a student asking, why is one not enough? Why is one not enough? In other words, he's saying that this is 3 and this is 9. Why is that not enough? That's such a great question. I agree with it. Why isn't what? No, isn't it relevant? It is relevant. It is relevant, but the problem is that we already know that those two angles are the same. In other words, look, in terms of like pairs, think about law of sines from pre-calc. These we already know a lot about that pair. We already knew the angle was the same. One doesn't really help because you know what? Do we know any if these two lines aren't parallel, do we know about this angle? Do we know about this angle? Do we know about that side? Do we know about that side? Do we know about that angle? Do we know about that angle? Do we know about that side? That side? We don't know anything. So you know what? You have actually overlapped your information with with 1, you've overlapped. You've given me double redundant information on that pair. You haven't given me anything else about any other pair. Whereas if these two lines are parallel, again, if these two lines are parallel, check this out. Now you know that this angle and this angle correspond, this angle and this angle correspond, and off the rip, those were the same. You knew that. So if all the angles are the same in a set of triangles, they are definitely similar. All right. So that was number 24. The last question I'm going to do before I open up to before I open it up to Q&A or any questions or anything, I'm gonna do this question really quickly. Congruency. Congruency is that these two triangles have to be the same. I have a lot of students that say A. I think Jack said A yesterday, that this angle and this angle are the same. If those two angles, if all three angles are the same, what does that prove? Congruency or similarity? A would prove similarity. Similarity, remember, is little baby big mama. Congruency is identical twins. I need to be identical. In other words, do I know anything about the side measures if I only know about the angles? Nah. Then, yeah, then I had a student say it was, I think it was, oh, and then I had a student tell me C. I almost screamed because look, AC and DE, that's crazy. That's crazy. They don't even look the same. So yeah, it's not C. And then I had another student tell me D. No, I mean, I don't know anything about the sides. Congruency has to do with sides and angles. Therefore, BC and EF being the same does prove congruency. All right, boys and girls, that, or just boys, that is really everything that I wanted to remind you of for the test tomorrow. That is all the little cheap little vocab stuff that I can get to you. Um, Outside of this, any like like kind of constant questions, do rely on one, your knowledge, two, a drawing, three, Desmos, four, scratching off answer choices that just don't make sense. And yeah, I have to remind everyone here just before I kind of end the lecture portion of this that you don't have to get every question right. In other words, towards the end of module 2, you don't need to get every question right. I know you guys come out of that freaked out, but you don't need to get a perfect score. I had a student get a 21, a 20. You have to lock in for module 1. Module 1 has to be razor sharp. And then I think she got a 15 out of 22 on module 2. She got a 740. So if it's a hard section, understand that everyone is kind of in trouble. And even this is like a D. This is like a D plus or something, D minus or something. That still got her a 740. So again, you don't need a perfect score. You just need to get all the cheap questions right, and I promise you your score will go up. But please, module 1 has to be razor sharp. Okay, boys and girls, that is it from my end. I did skip a lot of these questions. If you want me to go back and go through any of them, I am all yours, honestly, for the next hour and a half. My next student canceled. So if you guys want any help or have any questions, stick around. And honestly, even if you don't think you want to stick around, you might want to just because someone else's question might help you. So the floor is yours. If you want to message me, just message me publicly, just so I see, just so everyone sees the question. Or just open your mic and just ask me any question you want. The floor is your guys's. Anything that I sped through, anything I didn't make clear, let me know. If you guys want to head out, if you don't have any questions and you want to just dip, be my guest, you have done enough. But if you do have any questions, just message me, ask me, what's up? Even if it's a personal question, anything that you want to ask me. Kevin, best of luck tomorrow. Let me know how it goes. I want to see some text from everyone. Let me know what shows up tomorrow. I appreciate all you guys' hard work. It's gonna pay off, I promise. I love it. Tiago, best of luck.
Wait, could you pull up like the parallel line question where it's like, you know what I'm talking about?
I got you. I mean, I got a bunch, but this is a good
Like
one.
the no, the one where it was like a bunch of fractions. It was in the beginning.
Yeah, yeah, yeah.
Yeah, right there. Wait, scroll down. Scroll down.
Where am I?
Yeah, right there.
Oh, yeah, yeah, yeah.
All right, thanks.
Jack, I also sent you the link on this in case you want it.
Oh yeah, all right, thanks.
I have a question on number 36 on page 17. Uh-huh. This one. Colin, you ready for me?
Yeah.
Okay. So what I would do for this question is realize that that's a radius. That's also a radius. So what kind of question, what kind of triangle is that at that point? It's an isosceles triangle. If that's 20, then this is 20. At that point, there's a few ways to do this, but if that's 20 and this is really all 40, if that's 40 in the back of the eye, what am I in the front of the eye? 80,
Okay. I see that. Thank you.
of course.
Wait, how did you get the initial 20 degrees?
Yeah, I'll just do that one more time. Jack, ready?
Yeah.
If this is a radius, then that's also a radius. In that case, that's an isosceles triangle. Really, if that's 20, then that's also 20. If those are
Oh,
both 20, then together that makes 40, 40 to 80.
it doubles.
Yeah, remember, even this first question on 16, an angle in the back of the eye doubles to the front.
Yeah, but that wasn't like the front though.
It was. The back of the eye is 40. What's the front? 80. I know
Oh,
what you mean, but yeah, that it is. It really
oh,
is.
is the answer to the one I like asked 3.5?
Yes.
All right.
Yeah. All right, boys. Any last questions for me? Anything that you want me to talk about? Anything? Personal questions, Justin, how you feeling?
Good. I'm just kind of hanging around seeing if anybody has any questions that like I might find useful.
Yeah. How you feeling for tomorrow, Justin? I mean, I know you started like a week ago prepping for this thing, but I feel like you had a good foundation. What do you think? You think you got this?
I think I do.
Yeah, I think I mean, you really put in work this past week. How was your blue books? Did they come out all right?
Yeah. I've done really good on the blue books.
Good.
You know, with the exception of two, but one I had my best score I've ever had. So,
What'd you get?
730 on the math.
Nice, dude. Nice. We need that tomorrow, man. 7:30 tomorrow, we're done forever.
I would. Yeah.
Yeah. Page 19. 19, page 11. Which one, Colin?
Number 19 right there.
Yeah, yeah, yeah. All right. I wonder if you could pop this in Desmos. I think you can.
Okay, that's what I should do.
Um, that's what I would do.
And then you just do the slider until you get it like
No, I don't even think you
I
need
don't
a
know.
slider. I think you just pop it in.
Let's see.
Try it. Yeah, I think just pop it in. Jack, how you feeling with this stuff?
I'm good, just Desmos it.
Just Desmos. Yeah, it's crazy. I mean,
Is it five? Like,
for this question,
yeah.
um,
Oh wait, not five, I mean six.
honestly, I don't remember. I think it might be 6. I'm gonna try with you guys. Once Colin gets it, I'm gonna try. Did you just Desmos it?
Yeah.
Yeah. Colin, let me know what you
Yeah,
get for
my
this.
Desmos doesn't even like come up with any
Really?
like system. I know it's
Really?
like yeah,
All right, let me try.
Wait, did you put a X in instead of R?
probably should. Oh, let me do that.
Oh
Yeah.
yeah,
Okay,
you
there we
gotta
go.
put X in. Yeah.
There
And
we
that's
go.
the thing. A lot of my girls like just try Desmos and they give up. But nah, man, you gotta get dirty. You gotta try different stuff. They don't
I see
like
that.
Desmos. Jack loves Desmos.
Yeah, big Desmos guy.
Big Desmos guy. Guys, was I going too fast during the review? I feel like I was zipping.
No, that was like the point of it.
Yeah. I'm gonna end the recording now just in case. I'll end it. If you